Good morning, dear friends. Today our topic for discussion is the application of the concept of time value of money. You kindly remember that we have been discussing this topic and keeping continuing discussion on this particular topic, that is the time value of money. Today we just try to discuss or understand the various applications of the concept of the time value of money. Before I just start discussing the various applications of the time value of money, I just want you to recapitulate that the main objective of the financial management is to maximize the wealth of the organization or to maximize the wealth of the shareholders. Keeping in view this objective in mind, the finance manager has to take various decisions. He has to deal with various situations, asking for various decisions, and for this he may be using the various applications, the various techniques of the time value of money. For the purpose of use of the techniques of time value of money, he will have to understand the cash flow, which may be cash inflow or the cash outflow. He should also know the compounding and the discounting techniques which are available in the time value of money, and he should also know the application of these techniques. Only then a person can apply the various techniques in the time value of money for the purpose of making decisions or for the purpose of dealing with the various situations demanding the decision on his part. So you can't say that the time value of money will provide you the automatic way of providing the solution to the various problems. So experience and the knowledge on the part of a person in respect of the cash flows of the various discounting and compounding techniques, plus the application of the techniques of the time value of money, only then you can logically apply in the right sense the various applications of the time value of money. So for the time being, we can say the salient applications of the time value of money are: number one, you just see at this slide. The first is the finding out the rate of interest. Now we'll be discussing these applications, some of these applications. Now the applications are much more, they are very more in numbers, but for the time being we have just taken these 5-6 applications which are very, very important. So the first application of the time value of money is the finding out the rate of interest. Then comes the finding out the period of interest. The third is the sinking fund. The fourth is the capital recovery, and the last is the deferred payment. So we just try to learn with example the application of the time value of money. Just coming to the first, the finding out the rate of interest. You may be knowing that various financial institutions, they just issue deep discount bonds. Kindly remember and kindly note that in deep discount bonds, the rate of interest is not there. The investor, he invests a specific amount for the purchase of deep discount bond, and at the time of maturity, the amount which is payable to him is much larger than the amount for which he has purchased the bond. It means the difference between the maturity amount which he is likely to get after a specific period of time and the amount which he is just going to pay right now for the purchase of bond, it shows the amount of interest. So a person may be interested in knowing the rate of interest which he is going to get out of this deep discount bond over a period of time. So for the purpose of calculating the rate of interest, we can use the time value of money as a technique. We can explain this with an example. Here is an example. A deep discount bond is issued for rupees 5,000 today and will mature after 6 years. The rate of interest can be ascertained with the help of following equations. Here it has been issued at 5,000 rupees, whereas on maturity the amount would be 10,000 rupees. So we just want to know the rate of interest. So the rate of interest can be ascertained with the help of this formula. FV is equal to, it symbolizes the future value and is equal to the PV, present value, into 1 plus R to the power 6. So this R is the rate of interest that we have to calculate. Here the future value would be rupees 10,000 and the present value is 5,000, 1 plus R to the power 6. So this is the way we can calculate the value of R, and if we just simplify it, it will become R2 is equal to 1 and 2 divided by 1 by 6 is equal to 1 plus R, R2 1 to the power 6 minus 1 would be the rate of interest. If we just simplify it, we can calculate the value of R. Here future value, if we are given the future value, we are given the present value, and the time gap is there, that is 6 years. So for this time gap, we will have to calculate the value of R, which is the rate of interest. If you just simplify it, you can do it with the help of financial calculator also. So this is the way we can calculate the value of R, and the time value of money can be used as a technique for calculating the rate of interest. So now we just move to the next application, and the next application is the finding out the number of period, because sometimes one will be interested in finding the time over which a certain amount shall grow at a given rate of interest to a certain value. So in this case, the value of n, means the intervening period, can also be calculated. This can be explained with the help of an example. Example is that rupees 10,000 deposited in a bank that pays 10% rate of interest per annum, compounded annually. The investor goal is rupees 15,000. How many years must the principal earn compound interest before the desired amount is realized? So here the rate of interest is there. The targeted amount of 50,000 is also given. The value of 10,000, which is just right now, which is being deposited in the bank, is also there. But the person wants to know in how many years this 10,000 will become 15,000 at a rate of 10% per annum, which is the rate of interest, which is compounded on annual basis. So we can use the time value of money for the purpose of calculating the period. The formula would be same. Future value is equal to present value into 1 plus R to the power n. Future value here is 15,000. Present value is 10,000. R is given 10%. Here we are interested in calculating the value of n. This value of n can also be calculated by consulting the financial tables. By consulting the financial table, you can also calculate the value of n by simplifying it, or you can also take the help of financial calculator for calculating the value of n. N is a time within which this amount will become 15,000, compounding interest being 10% per annum. So this is the second application of the time value of money. The third application of time value of money is the sinking fund. One may be interested to accumulate a target amount over a given period of time, inclusive of interest for the period, in such a way that the annual amount being subscribed over the period is same for all the years. In such a case, the finance manager may be interested to accumulate a target amount in order to replace an asset or to redeem the liability. So the target amount, the target objective for any finance manager would be that he wants to accumulate a specific amount after a certain period of time, and that specific amount would also consider the interest factor in between. And second thing is that he is interested to accumulate a uniform amount every year, so that the target amount is available at the end of n period, means at the end of specific period. So this is called a sinking fund, and this particular requirement arises in the form when a person when the organization wants to replace the asset or they want to redeem the liability. The liability may be the redemption of bonds or redemption of debentures like that. So if this is the situation, you can say that they are just going to use this sinking fund technique. So time value of money helps in getting that amount. What would be the annuity amount? This can be explained with the help of an example. Here is an example. Just see, an amount of rupees 1 lakh is required at the end of 5 years from now to repay a debenture liability. What amount should every year at 10% rate of interest so that it ultimately becomes rupees 1 lakh after 5 years? So the question is very clear. The amount of 1 lakh rupees is required, and that amount is required at the end of 5 years. The rate of interest is 10%. Now we are interested in knowing that particular amount which we should invest as every year. The amount should be same, and ultimately it becomes 1 lakh rupees. So here we can solve this problem by giving this equation. Here F is equal to future value. Future value is equal to annuity amount into the compound value of an annuity. Here the future value is say 1 lakh rupees. Annuity will have to calculate, and this is the compound value of annuity for a period of 5 years at the rate of 10% per annum. So we can use the financial table for calculating the compound value of annuity equivalent to 5 years, and that too at the rate of 10%. If we just divide this 1 lakh rupees by this amount, we'll just get the annuity value which would be required to be saved or invested every year. So this is called the sinking fund use of the time value of money. Now similarly, we can also calculate or determine the capital recovery factors with the technique of time value of money. The capital recovery factor is that sometimes the person may be interested to find out the equal amount to be paid in order to redeem a loan of a specified amount over a specified period. And this particular situation may arise, for example, when you want to buy a car and you just take a loan from some of the banks. So in this case, the loan would be paid by EMIs, which are equated monthly installments. The EMI would be this uniform, and ultimately you are paying the interest as well as the principal over a period of time, that too at a regular interval of time. So if this is the case, it is called the capital recovery, where the amount of loan which you have taken, that would be repaid over a period of time, and the amount of installment shall also be uniform. So this can also be calculated or determined with the help of the time value of money, and the equation which we can use is that here we have just tried to explain this concept with an example. An amount of rupees 1 lakh borrowed today for the purpose of the car is to be repaid in 5 equal installments at the end of each year for the next 5 years, in such a way that the interest at 10% per annum for the intervening period is also repaid. The annuity amount in this case would be ascertained as under. So here our problem is that we'll have to pay the 1 lakh rupees. That 1 lakh rupees has to be paid in 5 equal installments, and the rate of interest should be 10%. Apart from that, the amount to be paid towards this loan at the end of every year for 5 years would also be uniform, means that should also be the same. So if that is the case, then we can calculate the value of annuity, and the formula for this is the present value is equal to annuity amount into present value of annuity factor. The present value of annuity factor, you can take the help of financial tables, or with the help of financial calculator also you can calculate the value of annuity. I think for this you should be fully aware as to how to read the financial tables, wherein you can find the value of present value of annuity factor. Here, for ascertaining the present value of annuity factor in this problem, you will have to see this table vertically. At 10% rate of interest, and for 5 years figures that would be there, and if the present value is divided by this particular present value factor, you will just get the annuity value, and that would be the amount every year that you will have to repay at the end of every year for 5 years. So this is the way you can calculate the capital recovery factor with the technique of time value of money. Similarly, sometimes you may also be required to calculate the amount in respect of the deferred payment. Deferred payment may be there when you have just taken a loan. For example, you have taken a loan of 1 lakh rupees and you just want to pay the loan in 5 equal installments. 5 equal installments means they may be 5 annual equal installments. Another requirement is that the 5 annual equal installments would be same. It means the annual installment which you are just going to pay in respect of the payment of loan would also be uniform. Number 3 point is that the first installment shall begin after a period of n years. It may be after 3 years, 4 years, like that. If that is the case, then it is a case of deferred annuity, deferred payment. I can explain my concept with the help of an example. You just see an example. Here, a loan of rupees 1 lakh is taken, on which the interest is payable at the rate of 10%. However, the payment is to start only at the end of 3rd year from now. What should be the annual payment if the loan is to be repaid in 6 installments? So here, 1 lakh amount has been taken. The rate of interest on 1 lakh is 10%, and the payment is to be made in 6 equal installments. But the first installment will be paid at the end of the 3rd year. So in this case, first of all, you will have to calculate the amount which will become due at the end of 2nd year, because the first installment will begin only at the end of 3rd year. So we will have to ascertain what would be the amount at the end of 2nd year. So for calculating this amount, you will have to calculate the amount at the end of 2nd year. So this amount would be 1,21,000. So this 1,21,000 is the amount which is due at the end of 2nd year, and this amount would be paid in 6 equal installment, and the first installment would be payable at the end of 3rd year, that is at the end of 1st year after this 2 years. The formula for that would be the present value is equal to annuity amount into present value annuity factor. Again, you will have to take the help of annuity tables. You will have to calculate the present value of annuity factor in respect of 6 years, that too at the rate of 10%, and based on that you can calculate the annuity amount which will be payable every year at the end of 3rd year for 6 years. So these are some of the applications of the concept of time value of money. For more details, I think you can refer to the books and you can do the examples on your own. Thank you very much.